Now in this session we actually analyze a real case of an NFA, step-by-step input symbol in the input string by input symbol, each read symbol by symbol, and it's quite detailed. You'll need to pay attention. There are a lot of steps, a lot of details in this session, but it'll give you a feel and a concrete case of how a particular NFA, non-deterministic finite automaton, how it works. Right? Well, here it is. Here's its state diagram, state transition diagram. So it's a four-state machine, and we have the two kinds of circumstances when you get copying. When the machine splits, it makes a copy of itself. One branches one way and the other one branches another way. There's two ways that can happen. I was saying in the earlier previous session. One of them is here. Have a look. The transition label here, you've got a 1, and you also got a 1 here, so they're the same. So you've got a choice. So when the machine is in state Q1, it can either loop back to itself, or it can transition to Q2. So there's a choice. So you'll have a split there. So one machine, the next state will be Q1, and with the copy machine, the second machine, it'll be put in state Q2. Right? So that's one way the machine splits. You get a branching in the computation. The tree-like structure is getting built. And the other way, look, you've got here an eta. So that means this Q2 will split. You'll get a machine copy is made, and one of those machines, one of the two, will stay in state Q2, and the other one will, its current state will be made Q3, the one that Q2 connects to, in a sense, the arrow towards, right? And so the two copies, one will be in state Q2, the other in state Q3. Those two machines are made at the same time. Okay, you don't have to, to make this one. You do not emphasize. You do not have to wait for the reading of the next symbol. Right? These two machines get made at the same time. But the first one gets put in current state Q2, and the second one gets put in current state Q3. Okay? Hope you follow that. If you're a bit hazy on that, rewind because it's basic. Otherwise, you will have like going from here to here. You'll have trouble understanding, analyzing this tree structure. All right, so let's. So here's the NFA. It's N1. Our first example of a non-deterministic fighter finite automaton, an NFA, right, with 4 states. So let's now analyze it step by step. So we see here the usual detached arrow. So we know Q1 is our starting state, right? And the string, well, from the previous session, I didn't mention it, but the input string for this machine is 010110. I'll say it again. Well, here it is written here, so time this way. So you read this symbol first, the second symbol, the third, the fourth, fifth, sixth. So 010110 in that order. Right? So, now I put the positioning, so the symbol here corresponds to the transitions. So, right, the transitions. So the positioning of these symbols is sort of important. Okay? Now, what do these states here mean? They're not just states. Well, manner of speaking. like for a start, the number of these states at a given level, like time's going this way, right? And like here's your start state. This is the state having read one input symbol. These are the states, in fact, the number of machines. Now we've got like 3 machines due to splitting. So we now have like 3 machines that now exist after having read two input symbols, right? And these will, and then one dies. We'll talk about that in a minute. So anyway, this one dies. So now we're just left with 2. So these are the machines in states Q1 and Q3 that exist after having read 3 symbols. And then we have 4 machines in 4 different states that exist after having read 4 symbols, and so on. Okay, so these states here at a given level is the number of them represents the number of machines that are working away independently of each other. Okay, number of branches, if you like, in the calculation, in the computation, that exist after you have read, let's say, little n input symbols. Okay? So this is, that'd be 0 if you like, times 0. So this is after having read 1 symbol, having read 2 symbols, 3 symbols, 4 symbols, 5, 6 symbols. Okay? Now there are only 6 symbols. Well, 6 digits, and that's a binary alphabet, right? Just 2 symbols in your sigma, and that's 0 and 1, right? The allowed symbols in your alphabet. So just the binary alphabet, 0 and 1. Okay, so let's now that you're clear, I think, on what these states represent. Why several of them. Well, there's at a given moment, the number of them. So in this case here, 5. You've got 5 machines working away independently due to splitting, to this branching effect. Because this is an NFA, a non-deterministic finite automaton. All right, well let's go through it now. It'll be a whole session, and it's rather detailed. I hope I don't fluff it, because there are a lot of little details. Right? So concentrate, and let's do a walkthrough, step by step. All right. Okay. So starting arrow. So we start in state Q1. Okay. We start here. We have not read any input symbols yet. So obviously we'll just have one here. We just have one machine going. Right? So we read the first symbol, and it's a 0. Okay? So we look at the state diagram, the state transition diagram, to see what we have to do. Okay? We're here. So we've got a 0. Now there are no multiple copies. Okay? It's just one exit arrow with labeled 0, and Q1 has no eaters. So each time you look at your next state, make sure that exiting from that next state, that there are no eaters. So you need to get into a new habit. These eaters, they're tricky, right? So okay, so there are no eaters. And there's only one what's the word? Instance? One example. There's only 1 0, right? Whereas the ones, there are 2 of them. So you'd get a branching. But anyway, the symbol at read is a 0, and there's only 1 of them. And so deterministically, we don't have any choice. We have to. The next state will also be Q1. Okay, so boom. So we're down to here. So now we're here. Now, Sipser, he advises you at each stage, at each level, each step, if you like. It's probably a good idea. Now he talks about fingers. I mean, literally fingers. There's only 4 states, so you got 4 fingers. You could put a finger on the state that's operating. In this case, well, this is your starting state, okay? and then you go to you stay in the same state after the 0, so you're still here. Okay, and as we go down, put a finger or fingers on the states, the current states at that step. And some of those fingers you'll have to remove because some branches might die